God's entire creation depends upon waves in different aspects. Therefore, waves are very fascinating to study. Waves are a type of energy transfer characterized by up and down, a series of up and down movements in molecules. The up moves become compressive, and down moves become trans. These are the type that you find in like water and air with sound. Unlike water and sound, though, there's a third type, electromagnetic waves. These have no medium, i.e. they don't have anything to carry them like sound or like air for sound or water for water waves. They do this because they have two waves at right angles that keep the other one going. The electromagnetic waves can be divided according to their frequency and wavelength. The frequency being the number of waves that pass given a spot in a second. Of average frequency are the waves that you and I see as light. But of higher frequencies, more cycles passing that point are the ultraviolet rays, the X-rays, and the gamma rays. Below that are the microwaves, the radio waves, and closer to the normal light rays, the infrared rays. I focused my investigation on the radio wave spectrum. Waves can do many important things. The first obvious answer is that they provide light for the entire world. Light is, as I said before, a narrow band of waves that our brains can interpret. Electromagnetic waves can also produce heat in objects. Two notable examples of this are the infrared wave band and the microwave wave band. The microwave wave band is often used for cooking food. The next almost more important use is the radio. The long distance communication is always required having no wires. Radios enable that by providing a medium to which you can interpret different codes. Well, an extension of this is wireless internet. There are two kinds of this: broadcasting from a satellite, such as 3G or 4G, or broadcasting for shorter range via a router. I based my experiment on how to improve upon the signal of our home's wireless router. As I thought out how to do this, I came up with the purpose to use supplemental antennae to benefit the wireless signal. However, there's a problem with this. Which antennae can benefit the wireless router the most, and which one should we use? My hypothesis or guess was that parabolic antennaes have a tendency to focus light on a point would be the best guess. For this experiment, again, the materials cardstock adhesive foil to create the supplemental antennae. Scissors and razor to cut it. A router and a laptop for getting the results. Tape measure a stopwatch for locating different stations and timing the results. My procedure began with printing out the antennae patterns and cutting them out. I attached the pieces together after gluing on foil to make the reflective surface. I treated for the other antennae because this was pure antennae. I had to vary the length just a little bit to create the V shape. The next step would have been the nail with a strength meter, but the laptop I was using already had the strength meter on it. I marked 6 stations at various points across the house, and these are recorded in one measurement every 10 seconds for 100 seconds per antennae, i.e. 10 measurements per station. 60 measures total were recorded per antennae pair. I averaged and made graphs out of the information I got from this. My results were I got a whole bunch of results, but here are a few averages per station for the antennae. Nothing under control was I included with these for reference purposes. Station A was near the router in adjacent room, the kitchen specifically. So nothing was 70.30%, the parabola was 73.90%, the V was 76.10%, the flat was 66.30%, the anti-parabola was 62.90%. The station average, although it is not really necessary for our report, it was just interesting to note. Node was 9.90%. B was in the garage, and this was the next room over, the same direction from the router as the kitchen was. Nothing was 56.40%. The parabola was 52.10%. The B was also 52.10%. The flat was 31.90%. The anti-parabola was 38.10%. The station average for this one, which was probably the worst location out of all of them, was 46.12%. C was on the opposite direction from the router and in my bedroom. Yet nothing was 76.30%. The parabola was 68.40%. The V was 69.00%. The flat was 70.20%, and the anti-parabola was 66.90%. The station average was the highest out of all of them except for F, which F really was had kind of viewing because I was later on. So it was 70.16%. Station D was down the stairs, and then on the corner of my brother's desk, and it was aside from the garage, the worst one. Nothing was 49.40%. The parabola was 57.00%. The V was 61.90%. That was 60.00%. The anti-parabola was 57.00%. The station average was 57.10%. E was located what would have been directly in front of the router, but down the stairs. And it was often, and just interested to know, we use this product for wireless more often than most of the other spots. Nothing was 68.90%, the parabola was 68.40%, the V was 69.30%, the flat was 70.50%, the anti-parabola was 69.60%, and the station average was 67.34%. F was used to test of our equipment as well as control for the stations, and everything on it was 100% of the world station average. Overall, for best signal, signal, the V's overall average was 71.40%, followed by nothing, 70.22%, the parabola, 69.97%. The flat, which was 66.48%, and the anti-parabola, which was 64.12%. My conclusion was that my hypothesis was rejected. V was the best overall, but the results were only the 1 or 2% off from each other. The use would be to manufacture signal straight using V shape, or perhaps for load matters print out these. Any questions?
So the V shape overall was the best one.
Yes, and it also helped improve the reliability of the signal.
That's interesting. What does your graphs show?
This would be the location in this. This would be my location, and this would be nothing, parabola, V-shape, flat, and parabola. It's just the antennae located with the different ones. This is the same information put by antennae in the station places.
So if you were going to extend this project, what would you, or if you'd change something about this project or you'd add on to it, what would you do?
I have several ideas. Perhaps I would use more shapes. Perhaps it'd be interesting to test the different stations or test the weather's effect on routers, signal. Maybe test some more around with this and figure out if there's a way to improve it. Anti-parabolas, although it seems to be kind of hopeless.
Very good. Thank you for sharing your project.